Very good morning to all. Today we are going to discuss about the multitasking and threading in Python. This topic is a part of the value-added course Advanced Python Programming for the second BTech AAML of SITRC Nasik. Okay, so let us see from the fundamentals. We are going to see about some basic concepts. In this. Okay, let us start. Multitasking is a process of executing multiple tasks simultaneously. We use multitasking to utilize the CPU in a best manner or in an optimal manner. Okay. So what is multitasking? Multitasking is a process of executing multiple tasks simultaneously. Why we use multitasking is to utilize the CPU in a optimal manner or best manner or efficient manner. Multitasking can be achieved by two ways. They are process-based multitasking, that is multiprocessing. It is also known as a multiprocessing. Thread-based multitasking, which is known as a multi-threading. Okay, so let us see one by one. Process-based multitasking, that is multiprocessing, is nothing but whenever we execute multiple tasks simultaneously, where each task is separate independent process or program, is known as a process-based multitasking. For example, you are typing a program in Notepad. At the same time, you can listen to audio songs from your PC or system, and you can also download a file from the internet. These three are independent tasks, but which can be performed simultaneously. Okay, that is, there is no dependence between one task to another task. The process based multitasking is best suitable at the operating system level, but it is not suitable for the programming level. Okay, so that's why thread-based multitasking is there, or it arises. Executing multiple tasks simultaneously, where each task is separate, independent part of process or program, is called as thread-based multitasking. For example, we are having a big program. That program is containing some portions which are independent. That portion we can separate, and that can be executed simultaneously while the program is being executed. Okay, so that's we will see in the further slides how it will be possible. Each independent port is known as a thread, and the thread based multitasking is best suitable for the programming level or programming level. For example, let us see that the program has a 10K line of code, that is 10,000 or 10,000 lines of code, where last 5,000 lines of code is depend on not is it does not depend upon the first 5,000 lines of the code. Then both are executing simultaneously, so it takes less time to complete the execution. See, this is the original program which is containing 10 lines of code, and it is divided into two parts. First 5K lines of code, that is 5,000 lines of code, and next part is the 5,000 code lines of code. So we call this particular first portion as a thread 1. We call the second portion as a thread 2. Now this thread 1 and thread 2 can be simultaneously executed, that is known as a multi-threading. Any type of multitasking is used to reduce response time of the system and improve the performance of the system. See, what is multi-threading? A thread is a lightweight process. In simple words, a thread is a sequence of some instructions within a program that can be executed independently of other code. Threads are independent. If there is an exception in one thread, it does not affect remaining threads. Okay, threads shares common memory area. See, thread is a lightweight process. Thread is a lightweight process. In simple words, a thread is a sequence of some instructions within a program that can be executed independently of other code. The threads are independent. If there is an exception in one thread, it does not affect any of the other remaining threads. But threads shares common memory area. Next is, so this diagram will show you the different processes which are independent of each other in a operating system. Okay, a thread is executed inside the process. There can be multiple processes inside the OS, and each process can have multiple threads. Now we will formally see what is multi-threading. Multi-threading is a process of executing multiple threads simultaneously. Multi-threading allows you to break down an application into multiple subtasks and run these tasks simultaneously. In other words, the ability of a process to execute multiple threads parallelly is called a multi-threading. You can, whenever if you are want to if you want to write in an exam, you can write any one of the definitions. Ideally, multi-threading can significantly improve the performance of any program. Multiprocessing and multithreading both are used to achieve multitasking, but we use multithreading than multiprocessing because threads shares a common memory area and context switching between threads takes less time than process. Okay. Next, advantage of multithreading. The multithreading can significantly improve the speed of computation on multiprocessor, and multithreading allows a program to remain responsive while one thread waits for the input and another wait for the uh, runs graphical user interface at the same time. Okay. Disadvantages of threading. So that threading raises the possibility of deadlocks. It may cause starvation when a thread doesn't get regular access to shared resources. This is the main drawback, okay, in the programming. Now we will see about the global interpreter lock. So execution of Python code is controlled by the Python virtual machine. Python was designed in such a way that only one thread may be executing in Python virtual machine at the same time, similar to how multiple processes in system share a single CPU. There are many programs may be in memory, but only one is live on the CPU at any given time or any given moment. Likewise, although multiple threads may be running within a Python interpreter, only one thread is being executed by the interpreter at any given time. Access to the Python virtual machine is controlled by the global interpreter lock. This lock is what ensures that exactly one thread is running. So this GIL, that is global interpreter lock, essentially means a process can run only one thread at a time. When a thread starts running, it acquires GIL, and when it is waits for input output, it releases the GIL so that other threads of the process can run. For example, suppose process P1 has thread 1, thread 2. Thread 1 is running, which will acquire GIL. Thread 1 is whenever thread 1 is waiting for IO, it releases the GIL. The same case is applicable for the thread 2 also. The pictorially which can be shown here. See, two threads are there. If thread 1 is running, it will acquire the GIL. If thread 1 is waiting for input output, then it will release the GIL and thread 2 will acquire GIL. Okay. So this is the program flow. And multi-threading modules. The Python programming offers two modules to implement threads in program. One is a thread module and another one is a threading module. Okay, what is this? The thread module provides low-level primitives for working with multiple threads. The thread module supports one method to create thread, that is thread dot start new thread, like that. This method starts a new thread and returns its identifier. It will invoke the function called specified as a function parameter with the passed list of arguments. When the function returns, the thread would silently exit. Okay. Here, arguments is a tuple of arguments. We use an empty tuple called function without any arguments. We can use we may not use tuple or arguments. So simply function. Okay. Next, this is the program for some small example for the threading module, thread module. So the thread can be started as from underscore thread import start new thread from the time import sleep define display n for I in the range of 5 print n start new thread display I again start new thread display hello sleep 2 print threads are executed. Whenever you execute this example, whenever you write some program in Python with this format, it will display a output like this. So finally, the result will be like this. Threading module. It is second module that is provided by the Python for the threads. The threading module provides more features and good support for the threads than thread module. The module provides thread class and thread. This thread class provides following modules. It can provide start, thread join, thread is alive, thread net game, get name, thread set name like this. So whenever we use thread start, then it will start a thread by calling the run method. Whenever we use thread join, it will join waits for the threads to terminate. Thread is alive. The thread is alive will be it is a clause which will check whether the thread is still executing or alive or over. Thread get name. It will returns the name of the thread. Thread set name. It will sets the name for the thread. Okay. So creating threads using threading module, the syntax will be like this: threading dot thread target comma name comma arguments. The target is callable function, name is the thread name, and arguments is the argument tuple for the function which is to be invoked. Okay, so this is about the multitasking and threading in the Python programming. So this we will see the simple program from threading import define f of function print hello from thread 1 t1 is equal to thread target f t1 dot start. Similarly, from threading import define function and print hello from thread 1 define function g is print hello from thread 2 t1 is equal to thread target f t2 is equal to thread target is equal to g t1 dot start t2 dot start. This t1 dot start and t2 dot start will display these two things like which are individually executed. And coming to one more feature which is supported by the Python is to create a lock. Okay, so to create a lock, use the line lock is equal to lock in parentheses. Locks have two methods we will use. One is acquire and release. Surround critical sections with acquire and release. The acquire method is called by a thread right before the critical section. Right before the critical section when it wants to lock. If the lock is free, then the thread can run in the code. If the lock is in use, the thread has to wait to run the code until the lock is free. The lock is freed by the release method. Already we had seen the GUL, that is. In the example below, we were, so I think this part, the example is not included in this presentation because it is a program. So leave that one. And condition variables. To create a condition variable called cond, we use the line cond is equal to condition parenthesis. Condition variables are built on top of locks, and anytime we want to do something with the condition variable, we have to surround the code with calls to acquire and release. The important methods of condition variables are those wait, notify, notify all. Wait is the condition which will process the current thread until receives the signal from another. Notify is one of the and one more condition which tells a waiting thread to stop waiting. Notify all. It is the condition in which if multiple threads are waiting, tell any of them, all of them to stop waiting. And coming to one more term you can come across in the Python is semaphores. Semaphores are versatile tool for working with threads. They can be used as locks or conditional variables, and they can be used to limit access to the shared resource to a specific number of threads. Because if one thread is, if one source resource is there, if all the threads are accessing that resource, then it will be problematic. The CPU might be in trouble to allocate to which thread it should reallocate the resource. In this case, the semaphores will help. The semaphores will be used to limit access to shared resource to a specific number of threads. Okay. For example, if we define SEM is equal to semaphore 5, then uh, it will uh, it will allocate only 5 threads. It can allow the CPU to share the resource to only 5. That semaphores have two useful methods. One is acquire, another one is release. Acquire, whenever a semaphore uses acquire, it will decreases the semaphore value by 1. Whenever release is used, it will increases the semaphore value by 1. Okay. So this is simply the summary of this particular class. And obviously, I had already provided you the program to execute the multitasking and multi-threading. So if you are having still any queries, you can easily contact me at any time. Thank you.